In this session, we'll run our first throughput test. So going back to the application suites, we can choose throughput. Remember, our port and client information will remain unchanged from earlier tests. So the clients that we defined earlier on are still there, no changes at all. The only thing that we'll see changing is on the test button, we now see we have throughput properties as a tab. As the test setup, our trial duration normally defaults to 30 seconds. I've set it down to 5 seconds just to make this video shorter. Notice that the loss tolerance is now no longer grayed out, and we can set the loss tolerance to some number. It defaults to 0. You can set it to 0.1%. In the throughput test, we will be doing a binary search, and the throughput is defined as the maximum forwarding rate at which the loss observed is below loss tolerance, right? So you can set it to 0.1% because there is a known issue in the IEEE standard for the PLCP header where you can get some occasional frame loss. You should never set this to 1% or 5% or any number greater than 1.1%. If a customer is doing so in order to get a higher throughput number, then they are really covering up loss that's happening in the access point. The throughput test is extremely useful because if you get a low number, then it's showing that there is loss happening in the access point with UDP traffic. And if it's happening at a lower number than is expected, it's worth going through and looking from the software point of view or the system point of view why that loss is occurring. Because any loss that's happening at a relatively low forwarding rate is going to impact application traffic, TCP traffic. So the throughput test should be loss tolerance of 0.1%. And as I mentioned before, I keep the settle time and aging time short. There's no device under test that should be buffering a second's worth of data at these high data rates. That would make for very long latency issues in a data stream. So those are the things we'll set up here. The advanced test parameter, I've selected that we can generate the report. And then we go to the throughput properties page. Now, the default is a variety of different frame sizes like you saw with the frame loss test. In this case, we're going to shorten this test and run only a 1518 byte frame. Now let's take a look at the binary search options. Remember that a throughput test is a binary search test, so it's going to start with an iLoad, and it is going to run that load for the trial duration. At the end of the trial duration, it's going to check for loss. And we know loss because we have a transmitting wave blade and a receiving wave blade. So we know exactly how many frames that we transmitted. We know exactly how many frames we received. So it's an end-to-end test. And any frames that were lost in the middle, we'll know about them. So we'll run that intended load into the device under test. The device will accept all the frames that it can. That becomes the offered load. And we'll look at what the achieved load, what was received on the receiving card, and check for loss. If there was no loss, then the test will be adjusted to increase the iLoad and attempt another trial. And this will be repeated with the iLoad increasing, ever cutting the distance between the last successful run and the search maximum in half every time it takes a step. So the search maximum we set as default is 150%. Why so high? Because we ought to be stressing the access point not only to the theoretical max, but beyond that. Now, the theoretical max is calculated by knowing the number of clients, the type of clients, what PHY rates they are configured for, and the frame length. All of that together, we can then calculate what the theoretical throughput is for that condition. So our starting point being 50%, we'll start out with an iLoad that is 50% of the theoretical max for our first trial duration, right? At the end of that trial, we'll check statistics on both the transmitting and receiving card. If there was no loss, then we'll cut the distance between that starting point, 50% that we just passed, and the search maximum, in this case 150%, and we will adjust the iLoad to 100% of theoretical max. and run the test again. If there was no loss, we'll keep dividing the remaining distance in half. If there's loss, we'll go in the opposite direction. When the next step is less than the search resolution, that's when the test is declared finished. Now we'll come back and talk about the O-load search option. So we are going to run upstream wireless to Ethernet. Let's press the button and start running. We see familiar text coming to the screen where we're checking for the firmware version. We are connecting up the clients, we ARP through, and now we'll see a progression, which is the binary search. We see we're running 5 seconds of traffic at 50%. Okay, that passed. We achieved that load with 0% loss, so we cut the distance between 50% and the search maximum, which we have set to 150%, and we run the test again at 100%. It passed with 0 loss, so we increased the load again. Halfway between 100 and 150 is 125. Ran that for 5 seconds. And you see that the distance between the last past iteration and the 150% search maximum, it continues to be cut in half every time we pass. And once we get to the place where the next step we're going to take is less than 1% of theoretical max, then the test will complete itself. And here we see that it did. And now we've got a report. So let's take a look at the report. It looks like the upstream throughput performance was right at theoretical max. So even though we tried to push a higher iLoad upstream, that's going to be governed by the rate at which the access point can acknowledge our incoming frames, and then we'll do random backoff. So we can see here that this access point is able to receive frames in the upstream direction at near theoretical max. Let's go down in the report, and we see that theoretical throughput is 595.6, and it got 543.4. So very good performance in the upstream direction for this access point. And we see latency numbers here, minimum, maximum, and average latency. In the upstream direction, we see that there were no retransmissions, no failed ACKs, and we got our report. If we go to the reports results directory, we'll just highlight that, copy it, go to we see the report that we just saw, we saw our console information, we see the configuration file and the time log, as we mentioned before. So all of that information is there. The results, if we want to go in and take a look at the results, there we see a comma-separated version of the results, and there are detailed pieces of information as well on each iteration. So how many frames were transmitted, how many frames were received. We can see the TX flow frames and RX flow frames. So if we want to see that level of detail, that's all in the results directory. So that's our first throughput test run in the upstream direction.